Hello and welcome back. This is your lead instructor, Gennaro here, CEO of Cortex Solutions. And today we're going to be talking about public key infrastructure brought to you by ACSMI. Let's get started. PKI, like we mentioned before, right, this is the process of utilizing two types of keys. Now it does help out a lot because we're able to say, hey, this person sent this data, and I know they sent this data because there's a digital signature associated with that, right? It helps with the ability to authenticate and say, hey, you're literally the person that sent this. I'm using non-repudiation now because I know. The fundamentals of PKI, which is public key infrastructure. We talked about there being two keys, the use of digital certificates, CAs, but let's break it down a little bit more. So you have public and private keys, and they work together. An example of this is Alice wants to send a message to Bob. She encrypts it with Bob's public key, and only Bob can decrypt it with his private key. That's it, literally in its simplest form. We talked about public key and private key. Everyone will know your public key, but not everyone's going to know your private key. Now, if a system was compromised and you still have that private key on your system in the folder somewhere, that's bad. Because now they can use that, upload that, or take that key. Let's say you had SSH enabled, right? They can put that instead and bypass. You don't need to use name and password now. So you want to keep that in mind as you go through. You have SSH now enabled and you're using and creating your public and private key infrastructure, okay? Now, digital certificates. Now, this is going to be issued by the CA, Certificate Authority. Now, these certificates, they're going to associate the public key with an identity of a person, organization, or a device. That's why I mentioned before that, you can have an organization and they can have digital certificates basically signed to them. And if someone were to self-sign that certificate and say, hey, this is me, and not really be me, well, there's a problem there. So a digital certificate, it's going to assure that the user, that website truly belongs to that bank. And I mentioned before, like a little example of, hey, it may be Google or it may not be Google, but you can definitely tell based upon that CA. So the CA is going to be the entity that's going to give and manage and issue certificates. The registration authority, or the RA, is going to act as a verifier. It's basically going to ensure that that user that's providing proper credentials before that CA issues the actual certificate. And then there's CRL, where it's basically a list of all the expired or revoked credentials to ensure that that entity can no longer use them anymore. That's good. You want to have that. You want to have all these in place to ensure that you have the correct fundamentals going on of PKI. But how does it work? Well, we talked about Bob and Alice. But now let's talk about the process, right? Doing a HTTP like browser, right? A PKI basically ensures that connection is secure. So this is pretty much how it works. The user is going to request a certificate from a CA through the RA. The CA validates that the user's credentials and issues the actual digital certificate along with the public and private key pair, as in just the public key, right? Now, other users are going to rely on the CA to validate the certificate holder's identity. What we're basically saying here is that we're able to have that secure communication because we went through that process of saying, hey, this is exactly how it happened. So when secure communication is required, you're going to go through this process of saying, hey, here's your digital certificate like I talked about before in a few previous videos. And then here's your digital signature. Like, hey, this is how it works. Well, in this case, a certificate instead of a signature, right? Because we're not talking about like, email. But all in all, this is kind of how it works. The ultimate goal of PKI is secure communication by far. A few of the core components of PKI and managing that are going to be the lifecycle. There's always going to be a certain lifecycle to certain things. Key escrow, lifecycle of the keys, certificate lifecycle or the actual certificate. The issuer is going to be the CA. I'm going to pretty much provide this new certificate if needed. Renewal is something that's saying, hey, I'm going to renew the certificate before it expires. And then when a certificate is no longer needed or no longer safe, the CA is going to revoke it and place it and track it on the CRL. Now, you can also do something called the Online Certificate Status Protocol, where it's going to look at a certain number, think of it as like a serial number, right? It's like when an employee leaves an organization, their old certificate or their old credentials must be revoked because, well, if they're not, that user has the ability to go in and say, oh, okay, let me log back in now. It's been 5 months. Let me see what's happening. You do not want those problems. All right, so root and intermediate certificates. Now, think about the hierarchy aspect of it, where you have your root certificates, and then you have your intermediate ones. And this is all about, adding layers, being able to distribute trust. If I know that this person is this person, or this entity is this entity, I trust this entity because, well, we trust each other. Web of trust, kind of keep that in mind as well too. Now, the protection of the actual keys itself. When you're going to secure an actual key, we're talking about key escrow here, talking about the lifecycle. You want to use vaults. You want to use something like HSMs or hardware security modules. This is a way you can securely store this key. But hey, I talked about it before. If you want to not utilize this and keep private keys out in the open, that's a bad time. You want to use the proper countermeasures in place, so safeguards to help do that. So when you're setting up a PKI system and you're setting it up from scratch, this is going to require methodological planning, right? Because think about it, you need to select the CA, you need to configure the RA, you need to make sure that the audit trail is intact, as in you're maintaining the records of each certificate as we issued them, because we do not want to lose something like that to the wrong hands. Now, some challenges are going to be scalability. There are many, many thousands of certificates in IoT ecosystems, okay? Some solutions could be, we want to include PKI management tools, but automation though, we want to automate it. And then being able to say, hey, we don't want our user misusing the certificate, as in leaving private keys exposed like I just talked about. This can break the trust in literally entirely. Right? Because if that's compromised, then you can basically say or impersonate someone, some entity. And we don't want that. So we want to also be ready for quantum computing. This absolutely endangers the process of any form of PKI algorithms. So we want to be able to prepare for this. So having an implementation of these keys and ensuring that you can manage them in such a way and then troubleshoot and being able to withstand this quantum computing, or at least be ready for it, is ideal. An example, and we talked about this pretty much before, but we can kind of talk about it a little bit more. When you're looking to sign something, you're using digital signatures to sign a document to verify that you are authentic and this is actually me and no one's tampered with this email. So when you're signing legal contracts, that's an example of it, right? When you're using digital signatures coupled with PKI, this just adds on this other layer. Non-repudiation is the key here, is the actual term, because you can't deny that you sent something now with your digital signature. But again, it's been great. This is Gennaro, CEO of Cortex Solutions, and we just pretty much talked about the use or the structure of PKI. Brought to you by ACSMI. Hope you have a great one. Look forward to seeing you soon. Thanks.